Good day, this is Professor Elliott, and in this short video we will take a look at the relationships between the voltage and the current in an NPN biased BJT. So a little bit of circuit orientation. Okay. Note the value of VCC is 15 volts. This meter is going to measure the collector current, collector resistor voltage, collector to emitter voltage, base voltage, and of course the base current. So the potentiometer here, which is note is being used as a rheostat, along with R1 and R2 form a voltage divider, and we're going to adjust the base to emitter voltage, hence the base current, by twiddling with the wiper position here. Okay. So for this simulation, a position of 0% means this is at its minimum position, which means visualize the wiper being all the way down here. Okay, you will note the similarity of this circuit to that of lab experiment 2. Okay, so with the wiper set at 0%, that means this whole thing is shorted out. So visualize the wiper down there. Sorry, the software I'm using, the wiper physically doesn't move, so you just have to visualize it. Anyway, okay, so note the base current. We have about 71 microamps, about 0.72 volts for VBE, which is what we would expect. Notice the very low collector to emitter voltage, so that means this transistor is presently saturated. And because of that, virtually all of the power source VCC, note the value here, appears across the collector resistor, so such that this plus this must always equal that. And notice we have about 7.4 milliamps. So I'm just going to move the wiper position, and that means we're increasing the resistance here. Okay, so imagine the wiper physically moving back up. Notice what happened to the base current, right? It changed. So I'm going to put it back to 0. Okay, 71 microamps. Okay, we decrease the voltage here by changing this. Then the current goes down. Okay, now note all the other readings and watch how they change as I step up from 0% all the way to 100%. Do you see as we move the wiper, the base current keeps decreasing? And with less base current, we have less collector current, which means the transistor is slowly coming out of saturation. Notice this voltage here is steadily increasing while this is decreasing. And always these two together will add up to that. And note the change in current. So let's go a little more. Okay, so we're well up into the active area now. Once this voltage gets becomes greater than about 0.7, the transistor is considered to be in the linear active operating area. So we're well in that region now. And as we continue to adjust the wiper, notice the base current continues to fall. The collector emitter voltage goes up, which of course is going to decrease the collector resistor voltage because it always has to add up to 15 volts. And that's just Kirchhoff's voltage law. So if I take it all the way up, 85, okay, notice the base to emitter voltage here, right? It's changed quite a bit now, relatively speaking. 90, 95, and 100. So now this wiper, visualize it being all the way up there. So it's at its maximum resistance value, right? We have about 4 milliamps here, about 8.3 here, and about 6.7 there. So the current here, sort of summarize, is determined by the base current here and the DC beta. So at any of these steps that we just went through, if you were to divide the collector current by the base current, that would be the simulated beta DC, which is the current gain. So anyway, take a look at the circuit in the lab experiment 2. You'll find this very similar, and I hope this has been helpful to you. Okay, see you all soon. Bye bye.